Lastly, we'll look at the sacrum. Besides being the lowest part of the spine, the sacrum is also an important part of the pelvis. Here's the sacrum, together with the coccyx. The sacrum is formed by 5 vertebrae fused together. From top to bottom, it has a marked backward curve. When we're standing upright, the sacrum is oriented just as we see it here. The upper part of this backward-facing dorsal surface is angled at about 45 degrees to the vertical. The upper part of this forward-facing pelvic surface is more nearly horizontal than vertical. On the dorsal surface, there are 2 articular processes for the 5th lumbar vertebra. The lowest intervertebral disc is quite wedge-shaped. Its shape accounts in part for the very marked curvature of the spine between the 4th lumbar vertebra and the sacrum. The most anterior point on the sacrum is called the sacral promontory. The vertebral canal continues down the back of the sacrum. From within the vertebral canal, the anterior rami of the spinal nerves, S1 to S4, emerge from these pelvic sacral foramina. The posterior rami emerge from these dorsal sacral foramina. The vertebral canal ends at this opening, the sacral hiatus, that's shaped like an upside-down V. This curved auricular surface articulates on each side with the upper part of the innominate bone or hip bone to form the pelvis. The joints between the sacrum and the hip bones are the sacroiliac joints. These joints permit almost no movement. The broad ridge on each hip bone adjoining the sacrum is the iliac crest. It's an important muscle attachment, as we'll see shortly. We'll be looking at the hip bone in more detail in the last section of this tape. For now, we'll return to the spine. Now that we've looked at the dry bones of the vertebral column, let's look at the structures that hold the bones together and that enable them to move. We'll look first at the intervertebral discs, then at the ligaments of the vertebral column, then at the posterior joints. These structures are arranged in a similar way from the top of the spine to the bottom. We'll be looking at all of them in the lumbar region. Here's an intervertebral disc. The disc is a massive pad of fibrocartilage that's firmly attached to the vertebral body above and below, all the way round the circumference. If we cut through a disc and look at it from above, we see that it's made of concentric layers of material. The disc consists of an outer ring of tough fibrocartilage called the annulus fibrosus and a soft center of almost liquid material called the nucleus pulposus. The disc is solid enough to transmit the weight of the body, and it's flexible enough to permit movement between the vertebrae. The side of the intervertebral disc forms the anterior margin of the intervertebral foramen, through which the spinal nerve emerges. The vertebrae are also held together by ligaments. Some of these go from vertebra to vertebra, some run the length of the spine. Starting at the back, we'll look at the ligaments which hold the spinous processes together, the interspinous and supraspinous ligaments. Then we'll look at the ligament that holds the laminae together, the ligamentum flavum. Then we'll look at the 2 ligaments which help to hold the bodies together, the anterior and posterior longitudinal ligaments. First, the interspinous ligaments. Here they are. They run from the lower edge of one spinous process to the upper edge of the next one. Now we'll add the supraspinous ligament to the picture. The supraspinous ligament merges with the interspinous ligaments. It runs the whole length of the vertebral column, connecting the tips of the spinous processes. The supraspinous ligament serves as a midline attachment for some important muscles, as we'll see later. These ligaments help to limit flexion of the spine. The structure, or structures, that chiefly limit flexion of the vertebral column is the series of short ligaments that hold the laminae together, which are known collectively as the ligamentum flavum. The ligamentum flavum lies on the front of the laminae. To see it, we'll cut through the pedicles of all the vertebrae along this line and look at the laminae from the inside. Here's the ligamentum flavum. It goes from one lamina to the next, all the way down the spine. Here, where it's been cut through, we can see how thick it is. The ligamentum flavum is made of yellowish fibroelastic tissue, hence its name, which means yellow ligament. Next we'll look at the two ligaments which hold the vertebral bodies together, the anterior and posterior longitudinal ligaments. The anterior is the stronger of the two. Here it is. The anterior longitudinal ligament covers the front and sides of the vertebral bodies. It runs the whole length of the vertebral column. We'll cut through it along this line to see it better. The anterior longitudinal ligament is thick and strong. It's attached to the upper and lower edges of each vertebral body. It limits extension of the spine. In extension, the tightness of the anterior longitudinal ligament helps to prevent backward and forward movement of the vertebral bodies relative to each other. The posterior longitudinal ligament runs along the back of the vertebral bodies. To see it, we'll divide the pedicles along this line again and look at the bodies by themselves. Here's the posterior longitudinal ligament. It's narrow where it overlies each body, and it widens out to cover the back of each disc. The posterior longitudinal ligament helps in a small way to limit flexion of the vertebral column. Each vertebra is attached to its neighbors not only by the intervertebral discs and the ligaments that we've seen, but also by the joints between the articular processes, the posterior joints. Each posterior joint is surrounded by a capsular ligament, which is loose enough to permit the small amount of movement that occurs between any two vertebrae. The capsular ligament has no great strength, but the articular processes themselves are strong. Because the upper ones face forward and the lower ones backward, the articular processes prevent the vertebra above from slipping forward relative to the vertebra below. Now that we've looked at the vertebrae and at the structures that hold them together, we're almost ready to move on to look at the principal muscles of the vertebral column. Before we do that, let's briefly review what we've seen so far. If you'd like to use the following review to test yourself, turn off the sound and name the structures as they're shown. Here's a cervical vertebra, a thoracic vertebra, and a lumbar vertebra. Here are the body, the vertebral canal, the pedicle, the lamina, the transverse processes, the spinous process, the articular processes, and the intervertebral foramen. In the cervical vertebra, here's the anterior tubercle and the posterior tubercle of the transverse process, and here's the transverse foramen. Here's the sacrum, the coccyx, the pelvic sacral foramina, the dorsal sacral foramina, and the sacral hiatus. Here's an intervertebral disc, the annulus fibrosus, and the nucleus pulposus. Here are the interspinous and supraspinous ligaments, the ligamentum flavum, the posterior longitudinal ligament, and the anterior longitudinal ligament.